Welcome back, everybody. We're taking a deep dive into vector databases today
Oh, yeah.
with this white paper, Vector Database Management Systems, Fundamental Concepts, Use Cases, and Current Challenges. I think this would
Right.
be a really cool one because I think a lot of people hear vector database and they think,
Oh,
oh, I know what a vector is,
yeah.
back from high school algebra, it's just an arrow on a graph, right?
Yeah.
But it turns out that's not really what we're talking about here.
So much more.
It's so much more, yeah.
Yeah.
So help us unpack this. What is a vector when we're talking about data science?
So, in data science, a vector, it's a way to represent complex features numerically.
Okay.
So it's not just like one number, it could be like a series of numbers
Yeah.
that together like capture the essence of something.
So instead of like just saying this is a,
Yeah.
like a red ball,
Right.
you would have numbers that represent like the redness, the roundness,
It's-
the size, maybe even the material. Like all those things could be captured in a vector.
Yeah, like imagine describing a cat with numbers. So like fluffy tail equals 9, grumpy face equals 3,
Hi.
love of naps equals 10.
Got it.
So those three numbers together create a vector that represents the cat.
That's a great analogy. I love that.
Yeah, and the paper actually gives this example of representing Greek plays as vectors, which I thought was really interesting.
Yeah.
So like you could have one number for how much tragedy is in the play,
Okay.
another for comedy, another for drama,
I gotcha.
and those three numbers would create a vector that represents the play's overall vibe.
Okay, so you're not just saying, oh, this is a tragedy. You're saying this is like,
Yeah.
9 out of 10 on the tragedy scale.
Precisely.
Okay.
And so this is where vector databases come in.
Okay.
They are specifically designed to handle this kind of high-dimensional data.
Got it.
Because, as you can imagine, like traditional databases, they weren't really built for this.
Yeah, so like trying to cram all these complex vectors into a traditional database,
Right.
that would just be a nightmare.
Exactly. It would be like trying to fit a square peg in a round hole.
Yeah, exactly.
Like traditional databases, they're great for structured data,
Mm.
like names, addresses, transactions,
Mm.
but they struggle with the complexity and scale of vector data.
And especially when it comes to like searching for similar things.
Exactly, especially when it comes to similarity searches.
Right, because if I want to find, all the Greek plays that are similar to this one,
Right.
it's not as simple as just like matching keywords.
Exactly.
You need to look at like the whole vector and how close it is to other vectors.
And that's where vector databases really shine.
Okay.
They excel at quickly and accurately finding similar vectors within like a massive data set.
So that's why we need a whole new type of database.
Exactly.
It's not just that we're being fancy.
No,
It's that the old tools just don't cut it.
precisely.
Got it. Okay, so we've established why we need them. Now, how do they actually work? Like, what's going on under the hood?
Real.
And I know we have this diagram in the paper.
Yes, figure 2 in the paper actually provides like a really simplified overview.
Yeah, so let's try to like walk our listeners through that.
Yeah.
So like imagine you have a piece of data, like, I don't know, a picture of a cat.
Right.
What happens first?
So the first step is to turn that data into a vector
Okay.
through a process called vectorization.
So it's like we're translating from like English to vector language.
Exactly.
But instead of words, we're using numbers to describe the cat.
Precisely.
Okay, and then what?
And then those vectors are stored in the database.
Okay.
And they're indexed for fast retrieval.
Now, indexing, that sounds kind of complicated.
Yeah, it's basically like creating a super organized filing system for your vectors
Okay.
so that the database can quickly locate similar vectors without having to scan through the entire data set.
So instead of like looking at every single book in the library,
Right.
it's like you have a card catalog that tells you exactly where to go.
Exactly.
Okay, and then what's the final step?
So when you search, your query is also turned into a vector,
Okay,
and the VDBMS finds the most similar ones.
so it's like matching fingerprints?
Yeah,
But instead of criminals, we're finding your perfect cat picture match.
exactly.
I love it.
And so there are various types of indexing algorithms,
Okay,
each with its own strengths and weaknesses.
so like some are faster, some are more accurate.
Exactly. And choosing the right algorithm really depends on the specific needs of the application.
Got it. So this is already getting pretty complex,
Yeah.
but I think we've laid a good foundation.
Yeah.
So let's move on to like the really fun part,
Yeah.
which is like, what can we actually do with this technology?
Yes. The use cases are where it gets really exciting.
Okay, so let's dive into those next.
So one of the most compelling areas, I think, where vector databases are making waves is image and video search. So like imagine being able to search for images based not on keywords or tags,
Right.
but on their actual visual content.
So instead of searching for cat wearing a hat,
Right.
you could upload a picture of your own cat
Yeah.
and find other pictures of cats wearing hats.
Exactly.
That's amazing.
Yeah, vector databases can analyze like the visual features of an image
Right.
and represent them as a vector, allowing for really precise similarity searches.
So it's not just like, oh, this image has the word cat in the file name.
Right.
It's actually looking at the picture and saying, oh, yeah, there's a cat there.
Exactly. And this technology is already being used
Okay.
to power reverse image search engines and content recommendation systems.
Got it.
So that's image search. Now, video search is even more complex.
Yeah, because now you have the element of time.
Right. You have the element of
You're
time.
not just looking at a single frame, you're looking at a whole sequence of events.
Exactly. But vector databases are being used to tackle this challenge as well. Yeah, so for example, they can be used to identify specific actions or events within a video,
Okay.
making it possible to search for videos of cats playing with yarn
Okay.
or videos of people dancing in the rain.
That's why. Okay, so image search, video search.
Mm-hmm.
What else? What other use cases?
Another area where vector databases are having a huge impact is in voice recognition.
Oh, yeah.
So think about the voice assistants we use every day,
Mm.
like Siri, Alexa.
Yep.
They rely on vector comparisons to understand what we're saying.
Oh, so when I say, hey, Siri, play my favorite song,
Right.
it's converting my voice into a vector
Exactly.
and comparing it to a database of known voice commands.
Precisely.
Wow.
And this technology goes beyond simple commands, right?
Okay.
It's also being used for things like speaker identification,
Oh, wow.
real-time translation,
Okay.
even for transcribing audio recordings with incredible accuracy.
That's incredible.
Yeah, it's really powerful. And I think one of the most fascinating applications is in the realm of chatbots.
Okay, I love chatbot.
Yeah, so imagine a chatbot
Mm-hmm.
that not only understands your current request,
Okay.
but also remembers your past interactions
Oh, that's good.
and tailors its responses accordingly.
So it's not just like, oh, I'm a chatbot, I have no memory of who you are.
Right.
It's like it actually remembers our conversation from last week.
Exactly.
That's really cool.
Yeah, so vector databases can act as a long-term memory for chatbots,
Okay.
storing vast amounts of conversational data, allowing the chatbot to provide personalized and contextually relevant responses.
So it's like talking to a real person.
It feels much more human.
Wow. Okay, so we've got image search, video search, voice recognition, chatbots.
Yeah.
These are all like really cool applications.
And they all rely on the power of vector databases.
Okay, so I want to talk about machine learning
Yeah.
because I know that's like a big buzzword these days.
Right.
And I'm wondering, like, are vector databases and machine learning connected in any way?
Absolutely. Vector databases and machine learning, they're like a match made in tech heaven.
Really?
Yeah, because many machine learning applications rely on vector representations of data.
Okay.
For example, natural language processing tasks like sentiment analysis or machine translation.
Oh,
They use vector embeddings to represent words and their relationships.
so you're saying like the building blocks of many AI systems are actually stored in vector databases?
Exactly.
Wow.
So vector databases are becoming like an essential part of the AI infrastructure.
Okay, so this is like way bigger than I initially thought.
Yeah, it's a really exciting field.
It's not just about finding similar cat pictures.
It goes much deeper than that.
Okay, so what's next?
Yeah, where do we go from here?
What are some of the cutting edge advancements?
So one of the most exciting areas of development, I think, is in the realm of indexing algorithms.
Okay.
Remember, these algorithms are what make vector databases so efficient.
It's like the heart of the system.
Exactly.
Yeah.
So researchers are constantly working on new and improved algorithms that can handle the growing complexity and scale of vector data.
So it's like a constant race to build a better search engine for vectors.
In a way, yes.
Okay.
And we're also seeing a lot of innovation in approximate nearest neighbor search algorithms.
Approximate nearest neighbor search algorithm. That's a mouthful.
I know.
What is that?
So these algorithms, they prioritize speed over absolute accuracy.
Okay.
So they're really useful for applications where getting approximate results quickly is more important than finding the absolute closest match.
So it's like choosing between a detailed map and a compass.
Yes.
Sometimes you need precise directions,
Right.
and sometimes you just need to know the general directions.
Yeah, got it.
Another area of active research is in the development of specialized hardware for vector databases.
Okay, now we're talking.
Yeah. So as we've discussed, working with high-dimensional vectors can be computationally intensive.
And traditional CPUs, they might not be the most efficient solution.
So we're talking about like creating specialized chips
Right.
that are optimized for vector operations.
Exactly.
Wow.
Yeah. So companies are actually developing chips that are specifically designed for tasks like vectorization,
Okay.
indexing, and similarity searches.
And these chips can like significantly speed up the performance of vector databases.
Exactly, making them even more suitable for demanding applications.
Okay, so the future of vector databases is going to be incredibly fast.
It's going to be blazing fast.
I love it. What else? What other trends should we be keeping an eye on?
So one trend I find particularly fascinating is the convergence of vector databases with graph databases.
Graph databases. Now, those are a whole other beast.
Yeah.
Like, I know they're good for representing relationships,
They're excellent at that.
but how does that tie in with vector databases?
So graph databases are great at representing relationships between entities. Right, and combining that capability with the similarity search power of vector databases opens up some exciting possibilities.
So it's like combining the strengths of two different database worlds.
Exactly.
Okay, I can see where that could be really powerful.
Yeah, this hybrid approach allows for like more sophisticated queries and analyses,
Okay.
making it possible to uncover hidden connections and patterns within data.
That wouldn't be visible otherwise.
Exactly.
That's pretty amazing.
It's really cool.
Okay, so it can't all be sunshine and rainbows, right?
Well,
What are some of the potential downsides
yeah, what are the challenges?
or challenges associated with these new developments?
Right. So one challenge is ensuring that these increasingly complex systems remain manageable and maintainable.
Okay,
So as vector databases become more sophisticated,
right.
they also become more complex to configure,
Mm.
optimize, and troubleshoot.
So it's like building a superpowered spaceship,
Right.
but needing a team of expert engineers to keep it running smoothly.
Exactly. And another challenge is ensuring the security and privacy
Oh, yeah, of
of the data stored in these databases.
Right, because as these databases become more widely adopted,
Right.
they become more attractive targets for cyber attacks.
Exactly.
Okay, so security is a big concern.
Absolutely. And as vector databases become more integrated with machine learning and AI,
Right.
we also need to address the potential for bias in these systems.
That's a good point. Yeah.
Because the data used to train AI models,
Mm-hmm.
it can contain inherent biases.
Right, because the data is created by humans,
Exactly.
and humans are biased.
Precisely. And these biases can be amplified
Okay,
if they're not carefully addressed.
that's a really important point to bring up.
Yeah,
It's like a reminder that technology is never neutral,
right.
and we need to be mindful of the potential consequences
Exactly.
of its use.
Well said.
So it sounds like with great power comes great responsibility.
Indeed.
Okay, well, we've covered a lot of ground in this segment. It seems like the world of vector databases is constantly evolving and expanding.
It certainly is. It's a really dynamic field.
Okay, so I think it's time to move on to our final segment,
Sounds good.
where we'll talk about the current state of the market and what the future holds for this technology.
Okay, I'm excited for that.
Okay, so let's shift gears a bit and talk about the current state of the vector database market.
Okay.
What's the landscape looking like these days?
So the vector database market, it's really booming right now.
Okay.
It's experiencing rapid growth and innovation.
So there are a lot of companies out there,
Oh, yeah.
both like big established players and startups,
Exactly.
who are developing and offering vector database solutions.
Precisely.
So it's kind of like a gold rush, right?
It is. Everyone's trying to stake their claim in this new frontier,
Yeah.
which is ultimately a good thing for users, though,
Right.
because this competition,
Right.
it drives innovation
Okay.
and pushes vendors to develop better products with more advanced features.
So what should someone consider?
Yeah. What are the key factors?
Yeah, when choosing a vector database.
Right. So as with any technology decision, it depends largely on the specific use case and requirements.
Okay.
But some general considerations apply across the board.
Like what's the most important thing?
I think performance is always a top priority.
Oh, okay.
You want a database that can handle your workload efficiently,
Okay.
especially if you're dealing with large data sets
Yeah.
or require real-time results.
So speed and efficiency are key.
Exactly.
Okay, what else?
Scalability is crucial.
Right.
As your data grows, you need a database that can scale seamlessly
Right.
to accommodate the increased load.
You don't want to hit a wall as
Exactly.
your application grows.
And that might involve distributed architectures,
Okay.
horizontal scaling capabilities,
Okay.
and the ability to handle increasingly complex vectors.
Got it. What about ease of use?
Oh, yeah. Ease of use is definitely important.
Because not everyone is a database expert.
Right, exactly. So look for databases that offer intuitive interfaces.
Okay.
clear documentation,
Mm-hmm.
and robust support.
Okay.
Some vendors even provide higher-level abstractions or APIs
Mm-hmm.
that simplify working with vector data
Yeah.
without requiring like deep technical knowledge.
That's always a plus.
Yeah, for sure.
Okay. Anything else to keep in mind?
Integration with your existing technology stack is also important.
Okay. Yeah, that makes sense.
So choose a database that plays nicely with your current tools and workflows.
So it's all about finding a database that fits seamlessly into your existing ecosystem.
Yes.
Okay. So we've got a good handle on the current landscape,
Mm-hmm.
the key considerations for choosing a database.
Yeah.
Now let's look ahead a little bit.
Okay.
What does the future hold for vector databases?
Well, the future is bright
Okay.
and full of potential.
Give us a glimpse into the crystal ball.
Okay, so one trend to watch is the increasing integration of vector databases with machine learning.
Okay, yeah, we talked about that a little bit earlier.
Yeah, and we're already seeing tighter integration between these two fields,
Right.
with the databases being designed to optimize the storage,
Okay.
retrieval, and processing of vector data used in AI applications.
So it's like the two fields are becoming even more intertwined.
Exactly.
Right.
And this integration will likely lead to
Yeah.
even more sophisticated and powerful AI systems.
Okay, so that's exciting.
Very excited.
What other advancements are you anticipating?
Another area where I think we can expect significant progress
Okay.
is in the realm of semantic search.
Semantic search, what is that?
So current vector databases, they primarily focus on syntactic similarity,
Okay.
meaning they compare vectors based on their numerical values,
Okay.
but future systems might be able to understand
Okay.
the actual meaning and context of the data.
Oh, that's interesting.
Yeah.
So instead of just finding documents that contain the same words,
Right.
you could find documents that convey the same ideas or concepts.
Even if they use different words.
Precisely.
Wow, okay.
That would be a major leap forward in search technology,
Yeah, for sure.
allowing us to find information in a more intuitive and human-like way.
Okay, very cool.
Another trend to keep an eye on is the development of specialized hardware for vector databases.
Okay, yeah, we touch on that a little bit.
Right. So we're already seeing companies develop chips
Mm-hmm.
that are specifically designed for vector operations.
Right.
And this trend is likely to continue
Okay.
as demand for high-performance vector databases grows.
So faster, more efficient, more scalable.
Exactly.
Okay, so we've talked a lot about the technology, but I want to shift gears for a second
Fine.
and talk about the human side of things.
Okay. Yeah, that's important.
What role will humans play in this increasingly automated world
That's a great question.
of vector data and AI? So as vector databases and AI systems become more sophisticated,
Right.
it's really important to remember that they are tools created by humans to serve human needs.
Okay.
While these technologies can automate many tasks and processes,
Yeah.
humans will always play a vital role
Okay.
in designing, developing, and overseeing these systems.
So it's not about replacing humans.
Yeah.
It's about augmenting human capabilities
Precisely.
and allowing us to focus on more creative
Mm-hmm.
and strategic tasks.
Exactly.
Okay, I like that.
And we need to ensure
Yeah,
that these technologies are used responsibly and ethically,
of course.
and that they serve to benefit humanity as a whole.
Well said. It sounds like the future of vector databases is full of promise and potential.
It is.
But it's up to us to guide this technology
Right.
in a direction that benefits society.
I completely agree.
Well, on that note,
Yeah.
I think it's time to wrap up our deep dive
Okay.
into the world of vector databases.
It's been a fascinating journey.
It really has. We've covered a lot of ground,
Yeah, we have.
from the fundamental concepts
Yeah.
to the practical applications
Right.
and the exciting future possibilities.
Yes, it's a rapidly evolving field.
So to our listeners, I hope you feel empowered to dive deeper into this topic
Absolutely.
and explore how vector databases might be relevant to your own work or interests.
And remember, the world of technology is constantly evolving, so stay curious.
Yes.
Keep learning.
Keep learning.
And who knows, maybe you'll be the one
Yeah,
to make the next big breakthrough in vector database technology.
that's right. Until next time, keep exploring and keep learning.